Hello friends, let's take a problem on a section which is a cutout section and we will find the centroid for such a diagram. So here is the question in front of us. Find the centroid for the cutout section shown in figure below. Here the diagram is given. For this figure we have to find the centroid. So in the solution part, for such kind of figure we would be dividing it into simple figures like triangle, rectangle, etc. So now what I'll do here, the figure which is given to here, it is uneven or we can say unsymmetric. It is unsymmetric means it is not symmetric about x or y axis. So here, since we have to locate the centroids, we need to find out x bar and y bar values. I will divide this figure into simple diagrams. So here will be section 1, section 2 and section 3. So for such kind of figure we need to find the centroid. Now I'll take one figure at a time. That is, first I would be taking the triangle. I'll separate this triangle. Its base is 20 mm and its height is 20 plus 20, that is 40 mm. So area for this triangle, which is first figure for us, A1, that's equal to half into base into height. So half into 20 multiplied by 40. Therefore, area 1 value will be 400 mm square. Then x1 is the location of y-axis, and as we know, y-axis will be located one third from base, or in other words, since here this triangle is kept at the origin at its apex, so from the apex y-axis will be at 2/3 distance. This distance will be 2/3 of 20. So therefore x1 becomes 2 by 3 of 20 and my answer is 13.33 mm. Next, y1 will be the location of x-axis for the first rectangle of here. I have the first triangle as the first figure. So y1 value will be, since I am measuring it from the base, it would be 1/3 of this height, which is 40. So this y1 value, it comes out to be again 13.33 mm. Next, I will take this second figure. Its width is 400 mm. Its height is 40 mm. So area 2 becomes 400 into 40, that is 16 into 10 raised to 3 mm square. X2 is equal to the location of y-axis, and that will be exactly at half. So y-axis is located at 200 mm distance, but since we are measuring the distances from the origin, so here I have 20 plus 200, 220 mm. y2 will be half of 40 mm. So y2 is 20 mm. Next, similarly, I'll take the third figure, and this third figure is a square having 20 as the side. Now, your area will be 20 into 20, that comes out to be 400 mm square. X3 is the location of y-axis. For the third figure, now this y-axis would be located at half of 20, and we are measuring the distance from origin. So figure 3, it is starting after 20 plus 400, so it is 20 plus 400 plus half of 20. So therefore x3 value will be 430 mm. Then y3 will be equal to, since this figure 3 is starting after 20 mm, so it is 20 plus half of 20. So y3 is equal to 30 mm. Once I have all the values, I can easily go for the calculation of centroid. I'll say that since location of centroid with respect to y-axis, it is given by x bar is equal to a1x1 plus a2x2 plus a3x3 upon a1 plus a2 plus a3. Therefore x bar will be equal to area 1, that is 400, into x1 is 13.33 plus area 2, 16 into 10 raised to 3, into x2 220 plus area 3, that is 400, into x3, that is 430. So here I have a1x1 plus a2x2 plus a3x3 divided by area 1 plus area 2 plus area 3. So therefore x bar value will be 220.08 mm. This is my first answer. Next, I will find out y bar. Location of centroid with respect to x-axis. I'll put the values here itself. Area 1 400 into y1 13.33 plus area 2 16 into 10 raised to 3 into y2, that is 20, plus area 3 400 into y3, that is 30, upon area 1 plus area 2 plus area 3. So therefore I will get y bar value. It comes out to be 20.08 mm. So from the calculation part, I am getting this answer, which is my second answer. Now once I have got x bar and y bar, I can easily show it onto the diagram, the cutout section which was given. Now this was the cutout section given. X bar value we have calculated, it was 220.08 mm. So this X bar is the distance of Y axis. Y bar is 20.08, so this much distance it was 20. So just above this. So once we have got X bar and Y bar, that is location of X axis and Y axis, their intersection will give us the centroid, and hence with the location of centroid we complete this problem.